Kuzuzampo, and good morning, afternoon, evening, whatever it is. Today I'll be talking about the Nernst equation. My main focus is the Nernst equation, but I will also be talking a little bit about finding the EMF using in a standard situation, in a standard condition. Okay, so let me give you some background information. Okay, we have two containers. These two containers are joined by a salt bridge. Can be anything, potassium chloride, anything. This salt bridge is made out of Vaseline. Okay, and we connect two wires here, and then we dip what? We dip copper here. Okay, we dip a copper plate in here, and here we dip a zinc plate. Now here we will add a copper sulfate solution. In here we'll add a zinc sulfate solution. Okay, and when we add these two solutions, current will flow, and voltage will be generated, EMF will be induced. So we can find this EMF by using the formula E naught is equals to E cathode minus E anode. Okay, we can find the EMF, the total EMF of this galvanic cell using this formula. E naught is equals to E naught cathode minus E naught anode. This is copper. No, this is copper. This is zinc. Copper has a value of negative 0.76 and zinc has a value of 0.34. Is it 0.34? And let's just take it as 0.34. Okay, I might not be correct. Anyway, the thing is that EMF will be induced, and in order to calculate the EMF under standard conditions, and by standard conditions I mean that the temperature is 25 degrees Celsius, the pressure is 1 atm, and both have 1 mole, so they're both equal. Okay, we use this formula. The cathode here is the one that is, well, the anode is negative, the cathode is the positive terminal. Okay, so anode here is the this copper plate, and the cathode is the zinc plate. Okay, so since cathode is the zinc plate, no, cathode is the anode, I mean the copper is the anode, we can just put the value here, and we can put the value here, zinc's value here. Okay, the cathode is the positive terminal, the anode is the negative terminal. This is negative, this is positive. The copper plate here is negative, and the zinc plate here is positive. Okay, so since this is the cathode, no, since this is the anode, since this is the anode and this is cathode, just put in the respective values and you will get 0.34 plus 0.76. E naught is equals to 1.1 volts. The total EMF of the galvanic cell is 1.1 volts. This is simple. Okay, now this is under standard conditions. What if the temperature is not 25 degrees Celsius? What if it is higher or maybe lower? What if the pressure is different? In that case, we use a different formula. We use the Nernst equation. Nernst equation. Okay, Nernst equation. Nernst equation. E cell is equals to E naught minus, wait, 2.303 RT divided by N F log of products divided by reactants. Before I start with any lesson, I like to give out the formula and tell them what they do. So here E naught is the value you get by using this formula, the one we used in finding the standard conditions, and the formula we used under standard conditions. Okay, this E naught is this, the one we used earlier. Okay, here the temperature might be different, maybe the pressure is different. Okay, so in this case we use this, and here this E naught is the EMF we directly find. Okay, this E naught here is the one we used earlier. Okay, minus NF. N is the number of electrons that was transferred during the reaction. F is Faraday's constant, R is constant, T is temperature in Kelvin. Okay, temperature in Kelvin. Log P. P here is product, moles of product, divided by R, moles of reactant. So earlier we had zinc 2 plus and copper 2 plus react. So how their reaction would have went would be like this. First you would have zinc and copper ions. Then you would have zinc ions, then copper turns solid. Okay, here the solid, in case of the cathode, the cathode is copper. Wait, sorry, the cathode is cuprous. The cathode is copper. Okay, the cathode is copper, so it will lose mass and become ions. The zinc are ions that will become solid. This is solid, this is ions. You know what happens at the end. In a galvanic cell reaction, the cathode loses its mass and becomes ions, and the anode gains mass and, well, gains more solid. Copper ions, no, zinc ions are deposited there. Now, in most of the time, in your exam, this never comes most of the time. What does come is this. In this case, the temperature, pressure and everything else are under standard conditions, except the both of the cells, the two solutions have different moles of different concentration of moles. Okay, when we use this formula, we use it when the two solutions have different concentration of moles. For example, this can be a cell, and here the concentration of, well, copper can be 0.1 mole, and here the concentration of zinc can be, well, 1 mole. In this case, where everything else is under standard conditions, but there is difference in concentration of mole between the two solutions, we use this formula. Everything here is same, product, mole of reactant, and number of electrons transferred. I am done explaining all the concepts. Now let us begin. Let's do a question. Lalu English hamagawa. Okay, so the question, I have a question here. Chromium 3 plus is equals to negative 0.75 volts, and Fe2 plus is equals to 0.44. It's negative. Okay, and they have different moles. So there's 1 mole, 0.1 mole of chromium, and in case of ion we have 0.01 mole. Can you identify which is the cathode and anode here? By the way, the concentration of mole does not change which is the cathode or anode. Oxidative state determines which is the oxidation, how much it can oxidize. Its oxidizing power determines which is the cathode and anode. So identify and wait. Done. Here the one with the lower value is cathode. No, anode. The one with the lower value is the anode. It's more negative. This is more negative. Okay. And this is the cathode. This is anode, this is cathode. Okay. One which is more negative is anode, one which is, well, less negative and more positive is the cathode. Simple. Now let us find, well, it's the EMF of this galvanic cell. Remember, it is not under standard conditions, so we can't just use the normal formula like we always do. We need to use the Nernst equation. Okay. But first of all, before we begin, we need to make a balanced cell equation, balanced reaction. Okay. Why we're doing it is because we need it to have an equal number of electrons transferred and an equal number of concentration of moles. Let me do it, you'll see. Either way, you will need to make a balanced equation. Okay, so consider Cr plus Fe2 plus becomes Cr3 plus Fe. Is this balanced? Let me ask you again, is this reaction balanced? These are the reactants, this is the product. Is it balanced? No, it is not balanced. Number of electron transferred is unequal. So what do? We make them equal. Okay, so we have 3 electrons transferred here. 2 electrons becomes 3 electron. Does not make any sense. Let us balance this. How do we balance it? Well, we need to make the number of electrons same. So how we do is that we have 2 numbers, 2 and 3. You need to find the lowest multiple of 2 and 3, LCM of 2 and 3. LCM of 2 and 3 is 6. 2 times 3, 6. So we need to make this side have 6 electrons and this side have 6 electrons. We need to increase the oxidative state either way. Okay. Yeah. So 2 electrons, we need to make it 6. 3 moles. 2 electrons. 2. 3 electrons, 2 moles of it, 6 electrons. Done, done. Now is more unequal. So there's 2 chromium here. Here it is 1. God does not like it, so make it 2. God also does not like it, so 3. Okay. Now we can see the total number of electrons transferred and the real concentration of moles of both sides. Okay, so what's the total transferred electrons? 6. 6 electrons are transferred here. So N is equals to 6. What is the mole of products? Mole of products. Well, this is constant. This is constant. Okay, don't forget this is constant. You don't need to just ignore it. And this is also constant. So you can ignore this. Ignore these two. Okay, you all need to focus on these two. So concentration of moles of product and concentration of moles of reactant. Concentration of moles of product. What is it? P by R. What is product? 2. Chromium. At the beginning in the question we had 0.1 mole. So we have 0.1 mole of chromium, but there are 2 of it. So we just square it, raise it to the power, and we have 3 here. So we also raise it to the power 3. Okay. Now what we do is, well, put in the value. You have N, you have P and R. Just do it. E cell is equals to E naught. Okay. E naught. We don't know what E naught is. Let us find E naught is equals to E cathode minus E anode. What is cathode's this oxidate cathode? Negative 0.44 plus, no, actually minus, sorry, minus, what was it? Negative 0.76, negative, negative, positive. What do we get? What is the answer? Negative 0.44 plus 0.76, 0.32. Oh, it was 75, sorry. 0.33. Yeah, put this value here. Okay, 0.33 minus 0.0591 divided by n. What was the number of transferred electrons? 6 times number of electrons transferred, 6 times log of concentration of products divided by concentration of moles. What was the concentration of products? 0.1 square divided by 0.01 cube. What is the EMF of this galvanic cell? Let's see, 0.591 divided by 6 times log of, with 0.1 square, 0.01, 0.1 square divided by 0.01 cube. Log 10,000 is 4. Multiply both, we get 4. 0.0591 divided by 6, you get 9.85 times 10 raised to negative 3. What's the answer? Times 4. 0.33 minus, the answer is 0.2906. We're done. Do you have any doubts? Actually, it was 0.31 here. Sorry. Man, simple calculation. So what's the answer? 0.31 by 9.85 times 10 raised to negative 3 times 4. 0.31 minus the answer, we get as 7.6 volts. We're done. This is all. Yeah, I'll send questions. I will post you can find the questions on ChatGPT. Yeah. This is all it. Thank you for watching. Support the channel. Bye.